Alright, so in this video we're going to cut the taper, then we're going to take the part out of the chuck, flip it around, and we're going to get rid of the material that I'm chucked up on right now, the extra material. And right, here I am, I'm loosening the compound. Like I said in the last video, I'm going to go over calculating the angle in person in the classroom. I'm not going to say what degree I just adjusted the compound to, but you can see it's a very slight angle. What I want to do to actually ensure that the angle is correct is I want to measure it with my 1-inch travel indicator. So I'm going to blue up the part, and then I'm going to make 2 marks on the part that are 2 inches apart from each other, because the taper length is going to be 2 inches long. Now we're opting to use the compound to turn this short taper because it's all that's needed. Later this quarter, when you make the hammer project, we're going to use the actual taper attachment on a lathe that has that as an option. This particular lathe does not have a taper attachment as an option. So here I am. I'm opening my calipers to a 2-inch distance. And again, I could have just laid a ruler down on the top of the part and then with a scribe made a mark at the end of the ruler and then 2 inches down the ruler. And that's a very good way to go about that. So again, the compound is the only thing that's moving at an angle. So I have to have the base of my indicator on the compound, because if I move the carriage to the left or to the right, it's going to go in a straight line. So I'm fiddling around here. I'm going to get it set. I want a nice rigid setup. I don't want it to be spongy. Now there I am. I'm positioning myself on one of the markings. I'm choosing to go to the marking that's on the left side of the part, so that way my reading is positive. So I zero it, and then again I move the compound, not the carriage, because the carriage goes in a straight line. So we're at 50, 80, I think 83 thousandths worth of movement. I can't remember if I show the camera, but I believe 86 would have been perfect, and I'm within 3 thousandths, so I say, hey, I can live with that. That's a very precisely set angle. We could get it closer to perfection, but for what this project is, that's plenty of accuracy. So now I will probably do a quick check to make sure that I have my compound set to where I do have enough travel to get all the way across the part. And then of course, don't forget to firmly tighten all of your compound bolts. When I'm first checking the angle, I only had 2 of them snugged up, just so it couldn't move when I was taking my readings. Now watch what I do here in the top camera. Oh, well, first it looks like I'm going to actually tighten my tool post down. That's a good place to start. But what you're going to see me do is I'm going to take that towel off my cart and I'm going to place it on the carriage handle. That's going to be a real big red flag that I should not put my hand on the carriage handle and move the carriage, because the only thing that's moving at an angle is the compound. And I know I've said that a few times, but there have been students who get this far into their project and then they grab the carriage and turn that handle and cut straight down their part and ruin it. So don't do that. RPMs again. I'm gonna maybe err at a little bit of overshooting the RPM, and that's gonna give me a better finish. So you can see my right hand is going back and forth on the compound, and then when I touched, I went to the right side of the part, I dialed the cross slide a little, and then I took a very small cut. And then I left my cutter on the left side of the cut. It's not touching the part. There's a very, very small gap, but it's definitely not touching. Now I'm going to do my best to get as close as I can to the end of the part and take a reading. Now I'm at 599, and I'm going to go to 0.437. That's my target. One thing I do here, and I got to admit, I kind of forgot that I was filming for students, and I sort of do these next two operations the way I would do them if it was just me. And what I'm saying is I get this done in two cuts, and I don't fool around. I just go straight for it. Um, Maybe I should have taken it in four passes, uh, because that's probably going to be more likely the case for you, the student. But it's also nice to see that, hey, look, we can get this metal off in a very timely manner. So as I start this cut, I'm using two hands. I'm alternating, uh, so I have constant pressure, because if I stop, I'm gonna get a tool pressure relief, and it'll leave a ring or a mark on the part. So you want to keep it moving the whole time. And there it is. It's fed off the part. I stop it. I was at 599. I take a reading. Now the reading I get better agree with where I was thinking I would be in my head. So always be checking your part size and also referencing, is that where I think I should be? The answer better be yes, or you need to figure it out. So here I am, run the numbers. I say I got 77 left to go. I could have taken that in two passes, but like I said, I think that my time was almost up for the day that I could spend filming, and I said I just got to get this done. So I return the cutter to the tailstock, then I dial the cut with the cross slide. And when I'm feeding, I do it as cautious as I can. And by cautious, I mean I want to maintain a consistent rate of travel. And you can see I have a really, really nice finish. Um, my chips are coming off silver. So now we're skipping ahead, and I got to get rid of all that extra material that I was chucked up on. So I could have just started facing it, but what I decided to do is first just get rid of this big knob, and I'm just going to turn it to a diameter of somewhere around 0.760. And the reason I want to get rid of that knob is I can pop my part out of this collet chuck, take it into the inspection room, and then lay out with the height gauge a very, very precise part overall length line. But if that shoulder was there, my height gauge, it would be difficult to get it a good clean marking. At least how I want to hold the part or set the part up on the surface plate. I didn't bother to film the height gauge scribing. That's pretty straightforward. And I wanted to stay away from my 0.752 diameter. So I just, you know, I'm showing you I'm at 0.840 now. And I believe I aim for 760. We'll see in a second. But I want to go back to the surface finish that I was talking about. And I ground that tool with a very, very small radius on the tip. And that's one of the reasons that it's getting a really good finish. The first time you sharpen a tool with your turn part project, I just want you to make a good tool. But at this point, now that you've ground a tool, um, if you want to talk to me and say, "Hey Nathan, how do I get that slight radius you're talking about to get a nice finish?" Um, we can go ahead and we can introduce that slightly more difficult operation. But when I'm first working with you students, I want to keep it as simple as possible so that way you're successful. And here I am, 768, good enough. I've gotten rid of most of the material. I can now see I have a good scribe line there. It's very visible, and I'm just going to face the part to that line. Now, when you're facing like this, when you're feeding in with the cross slide, do not get carried away, because if you have too much tool pressure and your part spins or moves in the collet, it's going to ruin your knurling where you're holding onto it. So you should feel very little resistance as you're feeding in. And I've sped up the footage here because these videos are rather long. So I was not feeding that fast when I was actually making this part. This is probably 4 times speed. But I'm just cruising in. I'm working my way to the line. And then after this, I'm going to cut my 45. Now, when I was in the inspection room and I marked that line for the overall length, I could have also marked another line a 1/16 of an inch down, and that would have been my line for my chamfer, which would have been a good idea. But if you do that, you better make sure that you don't get confused and face your part to that line, because, well, your part would be a 1/16 shorter than the print, which in the manufacturing world would be a rejected part. In the machine shop here, it would be a reduction in your score. We wouldn't start the part over, but we would definitely lose points on our grade. And I've turned the compound. It's at that 45-degree again. This time you can see I don't have the chuck jaws to worry about. I just have the rubber hand grip surface of the collet chuck, so I have more clearance. This video is just about to wrap up. In the next video, we're just going to drill the holes. It's pretty straightforward. Uh, I don't sharpen the tip of the gasket punch, mainly because I'm not going to use this as a tool. It's just a demonstration piece, and it's going to get dropped. And if I have it sharpened, like the final step informs you to do, um, understand that I'm not going to reduce your score if you don't do that sharpening. And I almost urge students to not do it, just because, again, if the part gets dropped, it will dent that very, very thin edge inwards. I have a couple tricks on how to get it back to round, but just keep that in mind. And just like that, I'm pretty happy. I checked the size, and it's time for me to go home, so I call it a day.